Welcome back, everyone. Today, we're diving deep into the technological marvels that make up large language models, LLMs, and generative AI. Whether you're chatting with a smart assistant, using a writing tool, or even generating art, there's a good chance an LLM is behind the scenes, working its magic. So, let's roll up our sleeves and get into the nitty-gritty of how these fascinating systems work. At its core, a large language model, LLM, is a machine learning model trained to understand and generate human-like text. It's not just any old program. LLMs analyze massive amounts of text data to learn the intricacies of language. Imagine having a super smart buddy who has read every book, article, and tweet ever written and can chat with you about virtually anything. That's the magic of LLMs. But here's the catch. These models don't understand language in the same way humans do. Instead, they learn to predict the next word in a sequence based on the context provided by previous words. It's like a supercharged autocomplete feature that gets better and better with more data. Now, how does one teach a computer to speak? The training process is a monumental feat involving three key components: vast amounts of data, neural networks, and serious computing power. First, let's talk about data. LLMs are trained on an ocean of text data. Think of books, articles, websites, and more. This data can reach hundreds of terabytes. Training a model involves feeding it this data, where it learns to predict the next word in a sentence. For instance, if I say, "the sky is," the model might predict blue based on patterns it has learned. Next up, we have neural networks, which are computational models inspired by the human brain. A neural network consists of layers of interconnected nodes, like neurons, that process information. When an LLM is trained, data passes through these layers, with each layer extracting different features and patterns from the text. But here's the kicker. Training LLMs requires a staggering amount of computational power. We're talking rows of powerful GPUs working tirelessly for days or weeks to churn through all that data. The result? A model that can generate coherent, contextually relevant text. If neural networks are the backbone of LLMs, the transformer architecture is the heart of the operation. Introduced in a groundbreaking 2017 paper titled "Attention is All You Need," the transformer architecture has fundamentally changed how language models work. So, what's so special about transformers? It all boils down to a little something called attention. In traditional models, information is processed sequentially, which can be slow and inefficient. Transformers, however, can process data in parallel, making them faster and more efficient. Attention is the mechanism that allows the model to focus on the most relevant parts of a sentence, no matter where they are. Imagine you're at a party where everyone is talking. Instead of just hearing random chatter, your brain can tune into one conversation while filtering out the rest. In the context of language models, attention allows the model to weigh the importance of different words in a sentence. For example, consider the sentence, "The cat sat on the mat because it was tired." The model uses attention to understand that "it" refers to the cat, not the mat. This ability to identify relationships and context helps the model generate more coherent and contextually appropriate text. The attention mechanism operates through a series of steps. 1. Score calculation. For each word, the model calculates a score indicating how relevant it is to the word being processed. 2. Weighting. These scores are then normalized using a function to create weights. The weights determine how much attention each word will receive. 3. Context. Vector. The model combines the input words based on their weights to create a context vector, which is then used for generating the next word. This ability to focus on different parts of the input text enables LLMs to understand long-range dependencies, making them more effective than older models. Once trained, LLMs become incredibly powerful tools for generating text. When you provide a prompt, the model looks at the context and generates the most likely next word, then the next, and so on, until it forms a complete response. It's like having a conversation where each response is crafted based on previous dialogue. For example, if you prompt an LLM with "once upon a time," it might generate a beautiful fairy tale. But how does it ensure the responses are coherent and relevant? That's where techniques like temperature and top K sampling come in. Temperature controls the randomness of the output. A low temperature makes the model more conservative, generating text that's more predictable and sensible. In contrast, a high temperature allows for more creative and diverse outputs, but it might veer into nonsensical territory. Top K sampling is another technique that helps the model generate interesting text. Instead of considering all possible words for the next prediction, the model only looks at the top K, for example, top 20 most probable options. This limits the choices and increases the quality of the generated text. While LLMs are trained on general datasets, fine-tuning helps tailor them to specific tasks. For instance, if you want an LLM to provide medical advice, you'd fine-tune it on medical literature. This specialized training helps the model improve its performance in specific domains, making it even more valuable for particular applications. As incredible as LLMs are, they have their limitations. For one, they lack true understanding and context awareness. They generate text based on patterns without actually comprehending the content. This means they can sometimes produce outputs that are factually incorrect or biased. Moreover, LLMs can also reflect the biases present in their training data. If the data contains stereotypes or prejudiced language, the model may inadvertently generate biased or harmful content. This raises important ethical questions about transparency, accountability, and the responsible use of AI. So, where do we go from here? The potential applications for LLMs and generative AI are vast. From enhancing creative writing and streamlining customer service, to aiding scientific research, LLMs are set to transform numerous industries. However, as we embrace these technologies, we must also tread carefully. Ensuring that these models are used ethically and responsibly will be crucial in shaping a future where AI benefits everyone. And that's a wrap on our exploration of LLMs and generative AI. We've unpacked how they work, their architecture, and their potential to revolutionize our interactions with technology. So next time you chat with an AI, remember the incredible tech behind those words. That's it for today. Take care, and I'll see you in the next episode. Who knows what we'll explore next? Until then, keep asking those big questions.